Okay, so now we are on section 4 for general soldering and assembly requirements. So for 4.1 solderability, components and wires shall meet the requirements of J Standard 002. Printed boards shall meet the requirements of J Standard 003. Remind me tomorrow in class to show you the neat trick on how you remember which J Standard supplemental document goes with which processes. It's kind of a neat little trick. When the solderability inspection operation is performed, that operation may be used in lieu of solderability testing. For solderability maintenance, the manufacturer should establish procedures to minimize solderability degradation. Removal of component surface finishes. Printed boards or parts are exempt from finish removal requirements when either there is evidence of no gold embrittlement or solder joint integrity problems, and if there are the ENIG, NIPDAU, or NEPIG, I call it NEPIG, finishes. Those stand for electroless nickel. Hold on, let me look in the book. It's actually in the PDF. Electroless nickel immersion gold, nickel palladium gold. That's the NPDAU. That's the nickel palladium gold. And the NEPIG is electroless nickel, electroless palladium, immersion gold finishes. For gold removal, they should be removed from 95% of the area to be soldered if the gold plating is greater than 2.54 micrometers. And it should be removed from all gold cups. I want you to remember that. Gold cups, regardless of thickness, should have the gold removed. We do a tinning process. When we do our gold cups, we do a tinning process that will, quote unquote, remove the gold. If there are other metallic surfaces that need to be removed, they should be removed from 95% of the surface to be soldered if integrity will be compromised. Typically, that's something that your engineering documentation will call out. Thermal protection. This is a thermal shunt, what this picture is showing. Protective measurements shall be taken for heat-sensitive components. Manual soldering shall have a documented process that minimizes risk of damage. If the iron tip makes direct contact with the part shall be discarded. And that would be a defect for all three classes. And there's an exception if the part of the documented process or a thermal shunt is used. Rework of non-solderable parts. So now we're on the next page of the PDF. We're at section 4.5. Leads, terminations, or boards not meeting the solderability requirements may be reworked before soldering. The rework part shall conform to solderability requirements, less steam conditioning. So you see here, before rework, the part is kind of dull and grainy, and after rework, it's shiny again and ready to be soldered. That looks like that was probably just tinned to try to build up that process, maybe. Pre-processing cleanliness requirements. The assembly shall be clean of any matter that will inhibit compliance to the requirements of the standard. That's basically saying no FOD. Everything that should not be on there needs to be removed. Parts not for general part mounting requirements. We're on 4.7 now. Parts not compatible with process temperatures shall be mounted and soldered as a separate operation. So you may have to hand solder something that's a little more thermally sensitive than something that could handle 245 degrees. This is about 475 degrees Fahrenheit. And this is, if you ever need to know the formula, it's 18C plus 32 equals F. So 225 degrees Celsius. I don't feel like doing math real quick. 1.8 times 225 is 405 plus 32. It's 437 degrees. That's 437 degrees Fahrenheit. General part, so still on 4.7. If cleaning is required, parts should be mounted with sufficient clearance. Like these are these little spacers. We will be installing these on our round parts when we get to hands-on. Assembly should be cleaned after each soldering operation. I will tell you that if you are having me inspect your hands-on work, do not hand me a sticky or dirty board. I will hand it right back to you. Parts should be mounted so that part markings and reference designations are visible. It's a should, not a shall. And also, as always, electrical clearance shall not be violated. When you have to install sleevings, like on this glass body diode, the sleeving shall be placed prior to component prior to installation, which makes sense, right? This is a tube. You have to put it on beforehand, because if you go to solder this, you're not going to have a way to get your sleeving on there. So put your sleeving on first. If you have an uninsulated part mounted over an exposed circuit, there should be clearance there, so it's not touching, for minimal clearance. Lead deformation. Leads shall not have nicks or deformation exceeding 10% of the diameter width or thickness. There is an exception for flattened leads. We'll talk about it more in the SMT module. There are leads that are flattened intentionally. They're called coined leads. This 10% rule does not apply to them. Parts and components shall be mounted so that they do not obstruct solder flow onto the solder destination sidelands. So again, we were talking about a little bit of physics yesterday. So see how this is so tightly down here. I'm going to change my, let's see if I can no, I don't want green. Green's not going to blend in here. Purple. So this is so tightly down here. No, let me use purple. There we go. So this is so tightly down here that there's no way for this air to escape. So there needs to be a little bit of a gap so that air can escape, so solder can flow. For metal case components, they do need to be isolated from adjacent electrically conductive elements. So here you have your metal component, your metal casing. Here's your hardware. They do need to be isolated from any kind of other conductive patterns. I want you to remember this picture. You may see something like this on the test. Adhesive materials shall not prevent an acceptable solder connection. Now we're on 410. That would be a defect for all three classes. Adhesive materials extending from under SMT components shall not be visible in the termination area. Now this is a question I've had students come up with, and I honestly don't know the answer. Because is this in the termination area or not? So if you see this question on the test, you use your best judgment, because I honestly do not know if this is in the termination area or not. So adhesive materials extending from under the SMT component, which this is, shall not A1, P2, D3 be visible in the termination area. So it might be in the termination area, and if so, it would be A1, P2, D3. Adhesive shall not contact an unsleeved area of a sleeved glass body component. So here's your sleeved glass body component, but you have this adhesive going in right here. That would be considered a defect for all three classes. Stacking of components. Typically your engineering documentation will call this out. So you see here, this is actually two components right here. When part stacking is permitted or called out by the engineering documentation, parts shall not violate minimum electrical clearance. So it can't be stacked so high that you actually, may contact another circuit on like another board inside the assembly. Connectors and contact areas. Mating surfaces of connectors and contact areas shall be free of contaminants or foreign material. This is your connector area, your contact area. This is a close-up of an area like this that has big blobs of solder on it. That would be a defect. Parts shall be handled in a manner to preclude damage, so you don't want to be, drop kicking these things across the factory floor. They need to be handled properly to keep them from breaking, keep any kind of solder connections from getting damaged, keep connectors from getting damaged. Once parts are mounted, the whole assembly shall be also handled in a way to where you don't damage your assembly. I have worked with operators before that did not follow this rule and did not transport parts properly, and they dropped a $60,000 display unit off of her cart because she was too lazy to go get a tote to put it in. She did that 3 times. The 3rd time was her last time. Assemblies with parts in solder paste should be handled to prevent parts from moving prior to reflow, and the solder shall be solidified prior to further handling. So this is a preheating oven. This is your preheat. Well, this is your preheat zone. Right here, it goes through as a conveyor, so it goes through a preheat, and then it ramps up, and then it reflows, and then it cools. There's actually a little chart that shows this and another slide. The assembly should be preheated to minimize presence of volatile solvents, so it basically cooks off any kind of alcohol or any other kind of chemicals that you may have on there that were used in the cleaning process. And it also improves solder flow, reduces thermal shock, and reduces the dwell time. And this process should not obviously degrade any of your components or your board. It's same with cooling. There may be controlled cooling. Again, that should not degrade your board or cause any damage. Holding devices, same rules apply. Shall not contaminate or damage any of your components or your board. So here's the ramp this diagram I was talking about. So it goes through the little conveyor, it's ramping up. It goes up 1 to 3 degrees Celsius per second. And once it gets to 150 degrees Celsius plus or minus 20, so that would be 130. 150 plus or minus 20 would be 130 to 170 degrees Celsius. And it is held there for 1 to 2 minutes, 60 to 120 seconds. That's your preheat. That gets it nice and warm, and then you ramp to peak 1 to 3 Celsius per second until you get to your reflow temperature, which is 270 degrees Celsius. You know what, hold on just to give you Fahrenheit, because just in case, because we are in America where we will measure anything except in metric. 130 degrees times 1.8 plus 32. So 130 degrees Celsius, this is 266. This is 200, this is 266 degrees Fahrenheit. 170 times 1.8 plus 32. That is 338 degrees Fahrenheit. 30 times 1.8. And then right here at 217 degrees, 217 times 1.8. 217 times 1.8 plus 32. We're looking at right around 423 degrees Fahrenheit. So it's like a really warm oven. That is where it needs to be for about a minute, plus or minus 15 seconds, to get that solder to flow, and then cooling at 2 to 4 degrees Celsius per second. So it cools pretty quickly. For non-reflow soldering, machine controls, there should be procedures, operating procedures that define applicable parameters and validations. And if there are adjustments that are needed per individual assemblies, that shall be identified. Solder bath. This picture kind of weirds me out because it looks like everything's on fire. I'm actually not even sure really what this is showing us, but it really looks like that is on fire. The exposure of any printed board to a solder bath shall be limited to duration that will not degrade the board or parts, as this is pretty much just a given for anything we do. And the temperature is based on the solder alloy in use and shall be set at a predetermined value with a tolerance of plus or minus 5 degrees Celsius. The solder bath shall be maintained with a purity in accordance with 322. Dross shall be removed, and that dross can be removed with either automatic or manual methods. One of my favorite things to do is to take dross off of a solder pot. It's just so relaxing. I love it. The manufacturer for reflow soldering, so this is reflow soldering now. Manufacturer shall develop and maintain operating procedures, shall include all operating parameters, and these steps may be part of an integral or inline system or may be accomplished through a series of separate operations. My thing disappeared. Sorry about that. My window disappeared for some reason, and you got to see a really short, quick second of one of my favorite pictures of my daughter and my son and our dog. So intrusive soldering, paste and hole. So this is if you put this solder paste, you basically fill the hole with it, you put the component in there, it goes through the reflow machine or the flow machine, and you come out with a completed solder connection. There should be evidence of wetting and adherence. Solder connections should have a smooth appearance. If there are marks and scratches, they shall not degrade the connection. And some alloys may have a dull, matte, satin gray, or grainy appearance. This is very common in lead-free. So lead-free has a dull appearance. It looks like a crumpled up aluminum foil is what it looks like to me. Like if you take a piece of aluminum foil, crumple it up really tight, and then smooth it out, try to smooth it out again. Even if you get it super smooth, it doesn't really look right. That is what lead-free solder looks like. However, those conditions are acceptable if it is due to only the material itself. So here is your good wetting angle. So remember, we're measuring from here. That's about 45 degrees. This one is, it's not as quite, maybe a little bit off. This angle is greater than 90 degrees. We are going to be looking at section 415 real quick, because I want to know why the difference is here. I actually, it's better than pictures than the others, I guess. So with your solder connection, I'm looking at the book now. All solder connections indicate evidence of wetting and adherence where the solder blends to the solder surface. The solder connections should have a generally smooth appearance. Marks and scratches shall not degrade the integrity of the connection. I'm just going over section 415 in the book now. Okay, so if we look at figure 4.2, that shows acceptable wetting angles. Wetting cannot always be judged by surface appearance. Solder alloys may, have different appearances. Solder connection wetting angle, which is your solder to component and solder to printed board termination, shall not exceed 90 degrees. As an exception, the solder connection to a termination may exhibit a wetting angle exceeding 90 degrees when it is created by the solder contour extending over the edge of the solderable termination area or mask. So that's what this is showing right here. It's going over the land, but that would be apparently okay, as long as it's not like going down here, as long as it's not blobbing out over here. Exposed basis metal. Exposed basis metal. So basis metal is the metal that is underneath your outside, the outside. So it's what's on the inside, basically. That shall not prevent an acceptable solder connection. So you can have some something exposed there, as long as you can still solder that component. This is table 4.1, solder connection anomalies. You'll see that most of these are defects. Blowholes and pinholes. Provided the solder connection meets all other requirements, it would be a process indicator class 2 and 3, acceptable class 1. So that would be written as A1, P2, P3. And then solder that obscures the stress relief bend of through-hole components. There's a picture on an upcoming slide that shows what this looks like. that would be A1, D2, D3. Okay, here are some pictures of anomalies. So you have fractured solder. Right there is your fracture. This is disturbed solder. This is solder that moved before, like the component was moved while it was cooling. Incomplete reflow. Let me see if I can zoom in on this. Yes, I can. So what this is paste that was applied to the top of this surface. Actually, that may be, no, that's not SMT. That's a through hole, it looks like. They had solder paste here that wasn't flowed enough. So this is what it looks like when it's properly flowed. It's nice and shiny. This just kind of looks like a bubble, like bubbles. And that it basically just needs a few more seconds under the heat to flow that properly. Cold connection, you'll see this solder is like not flowing down. It's sticking to itself. So non-wetting and de-wetting are very similar. They're not flowed down. They're not connecting the component and the soldered area. These can typically be fixed with just some reflow. Just applying a little bit more heat to it will typically get that working. And minimal electrical clearance violation right here. This is a little piggy tail of solder that needs to be that's like probably what happened is that an iron may have cooled, and when it was pulled away it drug the solder with it and created that icicle there. Solder contacts body. We'll talk a little bit more about this. This may be acceptable in some cases. We'll talk about the solder contacting the body of the component later, most likely during the SMT module. If it does not apply with wetting criteria, it's like this is too much. It's within the land. Let's see if I can zoom in again. Let me zoom in. Okay, it's not letting me zoom in. I don't know why. But yeah, you can see it's like curves there. So basically this is like almost like it's too much solder, because if we did get that good connection, it would probably go up here. It's just too much of a blob. That's a real simple way to put it. Solder bridge inclusion. So it's got a little piece of schmutz right there. Blowholes and pinholes. I want you to pay attention to this picture. This is another picture you may see on a test. Blowholes and pinholes, remember, are A1, P2, P3. And this is the picture of the obscuring the stress relief bend. Is that wire here? Is it here? Is it here? You don't know. You can't see where that wire is. And you need to have stress relief built in and needs to be bent properly. We'll get into more when we talk about wires and leads. But since that is obscured, you don't know where that is. So that would be a defect. Partially visible or hidden solder connections. Obviously, those can't be inspected easily because you can't see them because they're hidden. They shall meet the conditions that the design does not restrict solder flow, that the visible portion, if there are any, is acceptable, and that controls are maintained to ensure acceptable and repeatable process results. That is your important thing there. As long as you can continue to do that, the same results every time, that's what matters. Heat shrinkable soldering devices, solder sleeves. I was talking about these for a little bit yesterday. This is what a solder sleeve is. Where does my pen keep going? My pen keeps disappearing on me. Wire overlap for at least 3 conductor diameters. The solder preform ring is centered over the splice. So this right here, this is a little chunk of solder, is a ring of solder on the inside of the sleeve. And the preform has melted. I will probably call these solder sleeves from here on out, because I solder heat shrinkable soldering device or solder preform. It doesn't sound right to me. I've been calling them solder sleeves for 15 years, and I'm probably not going to stop anytime soon. that as long as the solder sleeve is melted and forms that wetted fillet so you can see where the solder is, and that there's no evidence of the preform outline, and that the contour of the conductor is discernible. Discernible is an important one here. And that no conductor strands pierce the sleeving. And that sleeving covers insulation on all wires by a minimum of 1 wire diameter. When using solder sleeves, typically the ones that we use in my work, there's a pigtail here. There's a little pigtail. Why is this doing this? As long as you're there, so there'd be a little pigtail there. See, what the heck? Why is it doing that now? Eraser. Hold on. I'm trying to erase these because now, like, all of them are showing up. Okay, that's really strange. Eraser. Eraser. You guys get to watch me fail at technology for a second. Hold on. Meltable sealing ring provides 360 degrees of seal at both. What the heck? Okay, I don't know if I fixed that. So anyway, wire strands are not exposed. Solder is not flowed beyond the sealing ring or extruded beyond the end of the heat shrinkable sleeving. So as long as you don't have solder coming out here, that would actually be a solder ball. That would be bad. Terminations made using solder sleeves are exempt from cleaning requirements because once you get that sleeving on here, you can't clean it. So that is exempt from these cleaning requirements. Please remember this. For threaded fasteners, hardware shall be installed in the proper order and orientation. They shall not interfere with adjacent components. They shall not be cross-threaded. They shall be free of nicks, burrs, distortion, stripping. Threaded fasteners shall be seated with mating surfaces with no gaps, and countersunk or flathead screws shall not protrude above the mounting surface. The sequence and torque pattern shall be in accordance with engineering documentation. Compounds such as like Loctite applied to fasteners shall not be applied unless identified on the engineering documentation. Erase all ink on slide. No. Gosh darn it. And if you are applying Loctite, they shall be mixed and cured following the material manufacturer's instructions or other documented procedure. And if those you have used Loctite or another kind of compound, that shall not be reused unless cleaned and inspected. Threaded fasteners need to be sufficiently tightened. Fasteners shall be tightened as specified. If you use a torque wrench, this is what this is a torque tool. Over torque fasteners shall be discarded because at that point you have you've potentially damaged your part. Sorry. Witness stripe is applied per 11.0. 11.0 doesn't even have its own slide anymore because it is that short. It's literally one section with bullet points. Okay, so the condition in this image, that is going to be a defect. I know for class 3, that is in the termination area. I am going to go ahead and say that's a defect for all 3 classes. Yes, that is a defect for all 3 classes. That is, this precludes the formation of acceptable solder condition. Oh my gosh, I keep accidentally hitting this. Gold-plated surface finish on gold cups. This is your keyword right here. It shall be removed when. It's like, oh, I know it's 2.5 and 2.4. Is it less than or greater than? I can't remember. No, neither. It's always. Always. Guidance for developing appropriate profiles for machine soldering. I don't know. I may have just breezed right over this, but I can tell you right now, it is going to be IPC 7530. Dude, why does it keep doing this? I keep accidentally hitting the side here. Okay. Cleaning and residue requirements. We are almost done, you guys, just so you know. Manufacturer shall qualify soldering and/or cleaning processes. Objective evidence shall be available for review. Extraction testing shall not be used to qualify a manufacturing process. Supporting evidence shall be test data demonstrating that the hardware will perform as expected in the service environment. And it may you may be using historical evidence, testing results, anything like that, as long as it is approved as considered objective evidence. Rework processes shall be included in the process qualification. Acceptability of the residue condition shall be determined just prior to the application of formal coating or on the final assembly. Please just remember that one. Or on the final assembly. Cleaning designator. This is cleaning designator C22. It is a generic all-purpose cleaning designator unless there is one that needs to be established. That is in table, let's see, we're at 8 now. Chapter 8. Sorry, I didn't go through yet. Chapter 8. So this is, it would be page 63 in the book. I'm not sure exactly what page it is in the PDF. So cleaning designator says table 8.1. You can always do a search for table 8.1, look for a designation of surfaces to be cleaned. Cleaning designator, you'll be able to find this quickly using the search function in your PDF. So the C, it means cleaning, and then these are two different designators. Tools, erase all ink on this slide. Ugh. So the C22, so you have C22. So both sides of the assembly are to be cleaned. Dude, what the heck? Why is this doing this now? Erase all ink. Erase all ink. So then you have, let's see, so C22 would be both sides of assembly to be cleaned, and you go down here and it's test for ionic residues required. So say if I had one that was, see, and then they keep disappearing, I don't get it. Say if I had C14. That would be one side only to be cleaned. Ugh, aggravating. Say if I, and also test for surface organic contaminants. So say if I had a board that no surfaces would be clean and no test required, that would be C00. If I had one that was both sides of assembly to be cleaned and test for rosin residues was needed, as well as test for surface organic contaminants, that would be a C214. So that'd be a C214. See, what is all? So for ionic process monitoring, when it has been defined and qualified per 8.1, ionic testing shall be controlled as follows. The manufacturer shall determine a sampling plan. Other methods may be used with user approval, and sampling plan shall define the test frequency. Make tools, erase all. Let's see if that works. I don't think it's going to work. Ugh, so annoying. The manufacturer, so for control limits, the manufacturer shall determine an upper control limit, that's your UCL here, for the ionic residue process, and shall have objective evidence available for review. So there's your UCL, and there's typically an LCL, which is the lower control limit. If the UCL is exceeded, it shall be tested on a new sample. If it's good, no action is required, but the investigation is recommended. And if the second test fails, there should document a disposition as a failure. Requalification requirements. Manufacturing materials and process changes are so major changes requiring validation, minor changes just need supporting objective evidence. For major changes requiring validation, that's level 1. That is when you're completely changing your flux, your geographic change, you're changing geographic cleaning agents. Geographic change means, like, if you're moving from Minnesota to Mexico, that's going to be a completely different environment. You have different methods that you need to, ensure that the you have one environment that's very maybe a little moist and colder, and then you go to a climate that's dry and dusty. Then you need to have those evaluated to make sure that that is accounted for in any kind of process changes. Minor changes shall be, if you clean your cleaning settings change, duplication of existing line, relocation of major equipment. Those things are not typically going to impact the solderability or the functionality of your parts or your components or your assemblies, but they should still be documented. Assemblies shall be free of foreign particles that are loose or violate minimum electrical clearance. We're talking about FOD now. Assemblies that are cleaned shall be free of visible residues which violate minimum electrical clearance, and all other visible residue requirements shall be as established between manufacturer and user. Non-ionic residues, rosin flux residues, testing is required. It should be in accordance with Table 8.3. When SIR is required, that shall include pass-fail criteria. And when the organic contamination testing is required, it should be in accordance with this IPC supplemental document. Ultrasonic cleaning process is only permissible on bare boards or assemblies without internal electronics. And if the manufacturer shall have objective evidence available for assemblies with electrical components. So if there are components on there, they need to prove that ultrasonic cleaning is not damaging anything. There is a white paper generated by IPC, white paper 019, to guide both users and manufacturers in respect to residues. Okay, Section 8 review. When rosin flux residue testing is required for a Class 2 assembly, that is going to be Table 8.3. For Class 2, this would be, there you go. So Table 8.3, Class 1, Class 2, Class 3. Class 2 is 100 micrograms. Right, there we go. Yep, 100 micrograms per square centimeter. Unless otherwise specified by design or by the user, the acceptability of the residue condition will not be on a board that will not be conformally coated. So I highlighted this earlier. So the board is not conformally coated. The acceptability of residue condition shall be determined at which point. So there was 2 conditions. It was either before conformal coating or after what? Does anybody remember? It was after final assembly. That is in Clause 8.1. Visible residues that have been identified as benign. So they have been identified as benign. Acceptable, all 3 classes. Erase all. Okay. Oh. When a major change is made to a qualified process, which of the following is required? Now, my first answer would actually be supporting objective evidence, but supporting objective evidence is part of something else, and that is the validation of the acceptability to change. Ink. Okay, ink tools, erase. This is so frustrating, you guys. Ugh. Okay, visible residues that have been identified as benign through prior laboratory analysis are what? Identified as benign is your important word there. That would be acceptable for all 3 classes. Right? Yes. When a major change is made to a qualified process, which of the following is required? Sorry, I had to go back and like exit out of PowerPoint, so I think I may have just kind of taken you through this slide twice. I apologize for that. When a major change is made to a qualified process, which of the following is required? So again, what I was saying before is the supporting objective evidence is required, but that's part of this. That is actually part of the validation of the acceptability of the change. Okay, see, now it's working again. All I had to do is restart PowerPoint. Okay. When no objective evidence is available, ultrasonic cleaning is permitted on what? Now, your keywords here are when no objective evidence is available. When no objective evidence is available, it is not allowed on anything with electronic assemblies. So we know right here, through process of elimination, the answer is bare boards. We have just a little bit. Nope, this is it. I think. Yep, we're just about. Let's see. Nope, we have a few more slides. So that was it for 8. Now it's on 12. This is rework and repair. It goes in a little bit more the difference between rework and repair. This explains it maybe a little bit better than I did yesterday. Rework is the act of reprocessing that ensures full compliance to all documentation. Hardware defects shall be documented before rework. Rework for classes 1 and 2 should be, and class 3 shall be documented. This is important to note. A second application of heat during hand soldering is not considered rework. That's just considered reflow, and that's part of the soldering process. So if you're reflowing, and then if you're putting your solder on, and then you go back to look, say, oh shoot, that didn't have a good angle, I didn't put enough on there, then you add solder to it, that is not considered rework necessarily. Now if I inspect it and say, oh, you don't have enough solder here, and then you're applying that, that would be considered a rework. Proper soldering technique is critical. That's why we're here. Hand soldering control shall include operator training, process controls, and management, and rework shall also, anything that's been reworked should still meet the applicability of this standard. Now, repair is the act of restoring the functional capability of a defective article. It does not necessarily assure compliance with applicable documentation because it's been repaired. So there would be, like right here, you see, so this little trace is broken and it's been repaired. This is not necessarily technically like per the documentation because it is a rebuild. But it would still be, that's what's considered a repair, not a rework. The defect shall not be repaired until documented, and it shall be established, the method shall be established between manufacturer and user. This isn't something a technician can just go do on their own. They would have to have engineering or something contractual from the procurement saying, yes, it is okay to repair this. After rework or repair, assembly shall be cleaned as necessary. process shall be established for cleanliness, and it also for cleanliness verification on conformally coated assemblies or assemblies that cannot be submerged after testing or for testing. So real quick review. So rework is the act of reprocessing non-compliant hardware in a manner that what? So remember, there's a difference between rework and repair. It's one of these two. So it's either A or B, and there's a difference between rework and repair. So it's one of these two. Which is it? It is ensures full compliance to applicable engineering documentation. Repair is the one that restores functional capability. So if we were repairing this, that would be this one. This would be repair. But rework is, it must comply fully. After rework or repair, assembly shall be what? Now, I'll tell you this. Dispositioning needs to happen before rework. So it's not this one. Process through functional testing. If it hasn't even been tested yet, you don't need to test anything. And thermal cycling tests, I haven't even talked about that. So we know right here, the answer, cleaned as necessary. And that is in clause 12.3. All right, this is the end of module 1. Thank you very much for your patience and my struggles with my pen. And I will see you all Thursday. Thanks.